Section 9.5 is on geometric series. A geometric series is the sum of the terms of a geometric sequence. And the formula for the sum of a finite geometric series is S sub n equals a sub 1 times the quantity 1 minus r to the n all over 1 minus r, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. Let's take a look at a couple examples here. So we need to find the sum of this finite geometric series. 3 plus 6 plus 12 plus 24 plus 48 plus a bunch of numbers plus 768. So let's go ahead and identify what we have here. So I know that a sub 1 is equal to 3. And looking at this, if I take the second term and divide it by the first and the third term divided by the second, I realize that my r, my common ratio, is equal to 2. And I don't know how many terms are in here because I don't know how many there are in between these plus signs, but I do know that my nth term, my last term, is 768. So I can use the formula for a geometric sequence to figure out what n is equal to. So that's, if you remember that formula, a sub n equals a sub 1 times r to the n minus 1. I know that my nth term is 768, and that's equal to 3 times 2 to the r minus 1. Dividing both sides by 3, I get 256 is equal to 2 to the n minus 1 power. I know that 256 can be written as 2 to the 8th equals 2 to the n minus 1. So 8 equals n minus 1. So n is equal to 9. Now I think I have enough information now to plug it into my formula. So the sum of this series is going to be equal to a sub 1, which is 3, times 1 minus r to the n all over 1 minus r. That's going to give me 3 times 1 minus 512 over negative 1, which, plugging that into my calculator, gives me 1,533. So that is the sum of that finite series. You can also use sigma notation to find the sum of a finite geometric series. Here we have our, well, let's go ahead and identify things here. So my first term is what I'm going to get when I plug in 1 in for n. So a sub 1 is going to be 2/3 raised to the power of 1 minus 1. Well, that's 2/3 to the 0, and that's just equal to 1. My number of terms, my n, is going to be 4. And my common ratio is this number that is raised to the power of n minus 1, or 2/3. So using my formula, S sub n is equal to a sub 1, which is 1, times 1 minus r, whoops, let's go ahead and put r in there, 2/3 to the 4th power. Actually, that's a little sloppy. I'm sorry, let me rewrite that. 1 times 1 minus, and I'm going to put my 2/3 in parentheses here because that gets raised to the 4th power. All of that over 1 minus 2/3. Let's clean that up a little bit. So that's going to be, well, I'm going to ignore this times 1 out front. So 1 minus 2/3 raised to the 4th power is 2 to the 4th power over 3 to the 4th power, or 16 over 81, over 1 minus 2/3 is 1/3. Plugging that into my calculator, I get 65 over 81 divided by 1/3. And use your calculator, use math, enter to turn it back into a fraction. I get 65 over 27. Not a nice number, but that is the answer. A geometric series can have an infinite number of terms and still have a finite sum. So the sum of an infinite geometric series is S equals a sub 1 over 1 minus r, where a sub 1 is the first term, r is the common difference with the absolute value of r less than 1. However, if the absolute value of r is greater than or equal to 1, the series does not have a sum. So to say that an infinite series has a sum means that it converges to a number as n gets very large. In other words, it heads towards a specific value as n becomes a very large number. This happens when the absolute value of your common ratio is less than 1. In other words, when your common ratio is a fraction. If the sum does not converge to a sum, then we say it diverges. This happens when the absolute value of your common ratio is greater than or equal to 1. Let's take a look at a couple examples here. Does the infinite geometric series 1 minus 1/2 plus 1/4 minus and so on into infinity converge or diverge? If it converges, find its sum. So what we really want to do is we want to find out what is the value of r. So r is going to be my second term, which is a negative 1/2, divided by my first term, which is 1, which is negative 1/2. So my common ratio is negative 1/2. The absolute value of that is indeed less than 1. Therefore, this sum converges. Now, let's find out what value it does converge on. So my sum is equal to my first term over 1 minus r. So 1 minus a negative 1/2, 1 over 1 plus 1/2, or 2/3. So this infinite geometric series does converge, and the sum that it eventually reaches is 2/3. And our last example here asks us to evaluate the infinite geometric series 1.1 plus 0.11 plus 0.011 and so on. Let's start by finding the common ratio. So I'll take the second term and divide it by the first term, and that gives me 0.1. And so since the absolute value of that is less than 1, this does converge, and so I will be able to find a sum. I also have a sub 1 is equal to 1.1. So using my formula, s equals a sub 1 over 1 minus r. That's equal to 1.1 over 0.9, or 11/9. So in this section, we took a look at geometric series, both finite and infinite geometric series, and how to find their sums, and for an infinite geometric series, how to determine if it converges or diverges.